In this lesson, we will be using the quadratic formula to solve quadratic equations. We will be able to tell how many solutions a quadratic equation has by the discriminant and also solve real-life application problems using the quadratic formula. To review, we want to remember what the quadratic formula is. X equals negative b plus or minus the square root of b squared minus 4ac all over 2a. So you can practice remembering the quadratic formula with the song Pop Goes the Weasel. Then if you remember that the section under the square root in the quadratic formula has a special purpose called the discriminant. The discriminant tells us how many real solutions there are to our quadratic. Remember, if that particular expression is positive, then there will be two real solutions. If b squared minus 4ac is equal to 0, then there will be one solution. And if b squared minus 4ac is negative, then it's going to be two imaginary solutions. If you recall, when we were to graph our quadratic function, when we are talking about solutions, we're talking about when we cross the x-axis. They're called the x-intercepts. So if we have two solutions, an example might look like this, where we have our parabola crossing the x-axis in two places. That would be two real solutions. And if we are talking about where our parabola has one solution, that means it's going to just have its vertex on the x-axis, and it will have one solution. Here's an example of what that might look like. And if we are talking about a parabola that has imaginary solutions, or it actually doesn't have any real solutions, then we would be talking about a parabola that does not cross the x-axis, and it might look something like this. So let's go ahead and do some examples. So first, we want to find the discriminant to tell us how many solutions there would be. In order to do that, our quadratic needs to be in standard form. So we're going to subtract 1 from both sides. So we have x squared plus 3x minus 1 is equal to 0. So we're going to use the discriminant b squared minus 4ac to determine how many solutions there would be. Remember, in standard form, our quadratic function is ax squared plus bx plus c is equal to 0, where a is the leading coefficient of the x squared, b is the leading coefficient of the x, and c is our constant term. So when we're plugging our numbers in, our b is going to be our 3. We're going to square the 3 minus 4 times a, which is 1, times c, which is negative 1. So we have 9. Negative 4 times 1 times negative 1 would be a positive 4. So that means that our discriminant is 13. So we will have two real solutions for this particular quadratic function. So let's finish by finding the solutions using the quadratic formula. So we have x equals negative b, the opposite of b is going to be negative 3, plus or minus the square root of b squared minus 4ac. Well, I've already calculated that to be 13, so I don't need to rewrite that whole thing. All over 2 times a. A is 1, so 2 times a would be 2. And we're going to leave this in simplest radical form. So here are the two solutions, negative 3 plus or minus the square root of 13 all over 2. Let's try another example. First of all, we need to get our quadratic into standard form, so we're going to subtract 2x from both sides. So we have x squared minus 2x is equal to negative 5, and then we'll add 5 to both sides to get it into standard form, setting it equal to 0. X squared minus 2x plus 5 is equal to 0. First, I want to use the discriminant b squared minus 4ac to determine how many real solutions we have. So the b is negative 2, so I'm going to square that, negative 2 squared, minus 4 times 1 times c, which is 5. So I have 4 minus 20, which equals negative 16. So I'm going to have no real solutions. I'm going to have 2 imaginary solutions in this particular problem. So let's finish by finding those solutions using the entire quadratic formula. So we have x equals negative b. Negative b means the opposite of b, which would be a positive 2, plus or minus the square root of b squared minus 4ac, which is going to be negative 16, all over 2 times a, which is 2. So we have x equals 2 plus or minus, recalling that this is actually going to be negative 1 times 16. The square root of 16 is 4, and the square root of negative 1 is I over 2. And then we can simplify because 2 can go into all 3 of our terms. So 2 divided by 2 is 1, 2 divided by 2 is 1, and 4 divided by 2 is 2. So our final solution would be 1 plus or minus 2i as the solutions to our quadratic equation. In our next example, we have negative x squared plus 2x minus 1 equals 0. It is already in standard form, so we're going to do b squared minus 4ac, and we're going to find how many solutions this will have using the discriminant. b is 2, so we have 2 squared minus 4 times negative 1 times c, which is negative 1. So we have 4 minus 4 equals 0. So that means we have one solution. And that solution would be the vertex of our parabola. Let's find that solution by using the quadratic formula. So we have x equals negative b, which is negative 2, plus or minus the square root of 0, all over 2 times a, which is negative 1. So we have x equals negative 2 plus or minus 0 over negative 2. So our solution would be x is equal to 1. And that would be where our vertex would be located. We can also use the quadratic formula to solve real-life application problems. If you recall that there are 2 formulas that we can use for dropping and throwing objects. In Algebra 1, those formulas, instead of using the HO, the VO, and the HO, they used this as the S, and then the VO they just used as V. So when we did Algebra 1, it was h equals negative 16t squared plus s, where s stood for the starting height of the object, t is time, and h is the final height of our object, and then v stood for velocity, vt, and s was our starting height. In the Algebra 2 book, you'll see it as ho and vo. So again, h is our height, which is our final height. Where did we end up? If we're dropping an object and it's landing on the ground or in the water, our final height would be 0. T stands for time in seconds. HO, our initial height. In Algebra 1, we used S, which was our starting height. And V stood for velocity. Then, the initial velocity could be, remember, velocity is talking about speed and direction, so we could be talking about a velocity that's positive, where it's going up, negative, going down, or the velocity could be 0, which is a horizontal launch. So let's take a look at a problem and see if we can solve using the formula. So we have a basketball player passing the ball to a teammate who catches it 11 feet above the ground, which is just above the rim of the basket, and slam dunks it through the hoop. This play is called an alley-oop. The first player releases the ball 5 feet above the court with an initial vertical velocity of 21 feet per second. How long is the ball in the air before being caught, assuming it is caught as it rises? So we need to use the formula h equals negative 16t squared plus vt plus s, because our problem is talking about throwing an object and includes velocity. H is the final height of the ball. and that's where the teammate is going to catch it at 11 feet. Remember that the negative 16t squared is part of the formula, and we are looking for time, so we won't fill in the t. The velocity, it is a 21 feet per second, and it's an initial vertical velocity, and the ball is going up, so that's going to be positive. And then S is our starting height, and it says that the first player released the ball at 5 feet above the court. So in order to solve using the quadratic formula, we want to get this equal to 0 and put our equation into standard form. So you have 0 equals negative 16t squared plus 21t minus 6. So filling in the quadratic formula, we have x equals negative b, which is negative 21, plus or minus the square root of b squared, 21 squared, minus 4 times a, which is negative 16, times c, which is negative 6, all over 2 times a, which is negative 16. Now we can use our calculator to do some of this calculating. 21 squared is 441 minus, because we have a negative times a negative times a negative, 4 times 16 times 6 is 384, and 2 times negative 16 is negative 32. So we actually have x is equal to negative 21 plus or minus the square root of 57 all over negative 32. Be careful when you put this into your calculator so that you tell the calculator that you want it to complete the numerator problem first, and then you're going to divide that answer by negative 32. So you could do it in a couple of ways. You could put this entire problem in parentheses and then divide it by negative 32. Or you could take negative 21 plus the square root of 57, then press equals, and then divide it by negative 32. So when we put that into our calculator and we round it to the nearest hundredth, we're going to come up with 0.42 as our first answer when we do negative 21 plus the square root of 57 divided by negative 32. And when we put it in the calculator and do negative 21 minus the square root of 57 divided by negative 32, and rounding it to the nearest hundredth, we get 0.89. So there are two answers for this problem, and the reason being is because when the first player releases the ball at 5 feet, the other player catches it at 11 feet, then puts it in the hoop, and then the ball is going to come back down. So notice that the question says, how long is the ball in the air before being caught, assuming it is caught as it rises? So as it rises is going to be our first answer. The second would be as if the ball were coming down. So this will be at 0.42 seconds. Let's review. Using the quadratic formula to solve a quadratic equation, use the discriminant to find the number of solutions of the quadratic equation, and then use the formulas to solve real-life applications, and then plugging those formulas you would use into the quadratic formula to finish solving. Please complete the reflection.